everyone, we're looking at question number 3 of winter 2018 paper 2-1 5054. Question reads, a student uses the apparatus shown in figure 3.1 to obtain the extension load graph of a spring. The weights of the loads are known. The student suspends loads of increasing size from the spring and determines the different extensions produced. Figure 3.2 is the graph the student obtains. We have extension and then we have load here, which is essentially the force, and this is the extension. The spring reaches its limit of proportionality when the load is 7 Newton. On figure 3.2, sketch the shape of the graph for loads greater than 7. Now before I move into this, there are a few things that I would want you to revise whenever we are having questions of extension load. Number 1 is the Hooke's law. Hooke's law. So essentially what Hooke's law basically says is that force is directly proportional to extension. When force is directly proportional to extension, and whenever you want to remove the proportional sign, you need to put an equal sign and put a constant with it. So I have F equals K, which is my constant, which is my limit of proportionality, K E. Now I know as I increase the force, my extension is going to increase as well, and what I mean by limit of proportionality is that it is the maximum point after which the force and extension are not proportional to each other any longer. That means, for example, if I have a spring right here and I attach a load to this, if I were to keep on attaching load up until towards limit of proportionality, it's going to extend, but then when I remove the load, it's going to come back to its original position. So it's like when I increase the force, my extension increases as well, and as I remove the load, as I remove the force, my spring will go back to its original. Let's say its limit of proportionality was, let's say, 7, and we crossed the limit of proportionality and we reached 9. I added so many loads, so many weights on this that it crossed its limit of proportionality and it reached 9. Now what's going to happen is that even after removing the load, the spring will not go back to its original position. It has now gotten permanently deformed, and that is the limit of proportionality, that up to a certain point force and extension are going to be proportional to each other, but after that point has been crossed, they are no longer proportional and the spring will become permanently deformed. So when they say, and as long as they are within the limit of proportionality, they are going to have a straight graph. As I said, whenever you have a directly proportional graph, you always have a line passing through the origin. Now they say when the load is 7, this is its limit of proportionality, after which it's going to lose, it's going to go beyond its limit of proportionality, and whenever you have that, they are no longer proportional and they're just going to go like this. It's going to curve in the upward direction, because 7 is the cut-off point. 7 is its limit of proportionality. 7 is its limit that after this it's no longer proportional, and so it becomes like this. And this direction, this curve is always going to be open to the extension side. Always make sure you remember that. If for example they give you a graph and you have load here and you have extension here, then the graph should look like this, because this opening of the curve should always be on the extension side. Done with the A part. Moving on, all the loads are removed from the spring. A block of wood is suspended from the end of the spring. The length of the spring increases from 4.9 to 13.4. Determine the weight of the wooden block. Simply go back, refer to the graph. They have given me extension, I need to find extension. Now what essentially is extension? Extension is how much it extended, how much, what was the increase in its length. It was initially 4.9 and then it increased to 13.4. So what was the increase? It was 8.5 centimeter. So my extension is 8.5 centimeter. This is my extension. Now they want me to find the weight, which is the same as load, force, whatever you want to call this. 8.5. Now that I have gotten my extension, that is 8.5, which is 6, 7, 8, 8.5. It's almost around till this part, and then it's 3.2 here, so it's almost 3.1 to 3.2. You can write any number. I'll just go with 3.15 to be safer. 3.15 Newton. Moving on towards the C part, that says the student takes a second spring that is identical to the one in figure 3.1 and hangs it next to the first spring. Figure 3.3 shows a light rod passing through the ring at the lower ends of the spring. The student repeats the experiment and gradually increases the load to 9 Newton. Now that's a huge number, 9 Newton. State and explain whether the limit of proportionality is reached. Now, if I was using just one spring and I had attached a load of 9 Newton, I go back and I see its limit of proportionality was 7 Newton, after which if it was 7.1, 7.2, 7.3, any number that's greater than 7, that would have meant that I have crossed the limit of proportionality. But in this case there are two springs, so if there are two springs hanging side by side, it's like they're sharing the load. This spring is saying that let's take half of the load. I take 4.5, you take 4.5, so we're not burdened. So essentially, if you're having 9 Newton load here, half of the load goes here, half of it goes here, so essentially you get 4.5. And since 4.5 is less than 7, that means it is still within its limit of proportionality. So I will say the limit of proportionality has not been reached. Limit of proportionality is not reached because the weight of 9 Newton is shared equally. That's extremely important because we have similar springs, so both will be taking 4.5 Newton, is shared equally among the two springs. Hence, each spring gets a load of 4.5 Newton. And this is it for the C part and for question number 3.